Okay, so on to really our last formula we're going to take a look at, and then we're just going to dive into a few examples and exercise sets once again. So I'm going to give it a little space for this one. So this is a formula given to find the monthly payment for a loan. It's kind of scary looking, but as long as you know what everything represents, and then it just becomes a problem for order of operations. Okay, so the P is still the principal. I is the monthly rate. So here it's a little bit different. So the monthly rate. So remember, rate is in regards to percentage. So when we're doing this, we're going to calculate a percent divided by 12. So typically when you get a loan, it's like it gives you the rate of the chunk, and then when we figure out the monthly rate, we just divide that by 12. And then N is our time. And then since we're figuring out monthly payment, this is going to be months. Time in months. Okay, so let's take a look. Just a pretty example 5 is a pretty simple application of this. Really, it's going to give us each piece of information, and then we're just going to have to plug it in and calculate it. So it's going to look really messy, but it's really the similar process we've been dealing with. So use the formula to find the monthly payment on a $175,000 loan, 6% rate for 15 years. All right, so if we're looking for M, we're going to put in 175,000 as the principal, and then remember that I is our monthly rate. So it looks like so 6% means we're going to have 6% divided over 12 months. And then this is all divided by 1 minus 1 plus that same 6% over 12. And that's to the negative number of months. So it's 15 years, 12 months a year. That's going to end up being 80 months. So an 80 month. So that's going to go down there. All right, so let's simplify this a little bit. So 6% divided by 12 is 0.005. So I'm just going to replace these two values with 0.005. There we go. So M equals 175,000 times 0.005 all over 1 minus, and then I'm going to add that to 1. So 1.005 to the negative 80 power. So if it helps you, just break this down into pieces. So I'm going to break it down into the numerator and the denominator, and then we'll do that division in the end. So 175, excuse me, times 0.005. All right, 875 in my numerator. All right, my denominator is going to be 1 minus 1.005 to the negative 80. All right, so this is we can round probably to the thousandth, so the third decimal point here, and then we're going to be getting an approximate in the end. All right, so let's do this division, and then we'll get our monthly payment for this loan. So we're looking at $2,659.57. This seems a little high. So let's just double check this with the massive equation. I'm going to do it all in one swoop. Times over 12. Okay, we'll close that up, and then we have 1 minus, oops, 1 plus. So if we were to do it all in one chunk, this is what it would look like. Oops. 12 times 15. All right, so I did something wrong in the beginning. So this is actually the number that we want, so sorry about that. That's why I wanted to double check it here. So that is the one piece about doing things in components is sometimes it doesn't get you the right thing in the end. But if we look at this, we filled in the principal, we filled in our rate divided by 12, so we get a monthly rate. 1 minus the quantity, 1 plus rate divided by 12 to the power, negative power of the number of months, 12 times 15. And so our monthly payment is going to be $1,476.75. Okay. All right, so let's look at one of the exercises that you might encounter. So on page 799, they give you a series of amounts, rates, times, taxes, insurance, and we are asked to find the monthly payment. So this is going to match problems 5 through 10. So this is going to match the exercises 5 through 10. So the rate is a percent, so we'll need to account for that. So you're going to use that table once again on table, what did we say, 13.4? Is that the table we want? It gives us the monthly cost per $1,000, depending on your time and your rate, right? It's the column in row. Column is time, row is rate. So if we use that table with these two, 6.5% in 30 months, we're going to get 6.32 per thousand. So if our loan amount is $150,000, then your monthly cost for the loan is going to be 150 times 6.32. Okay. So $948. So the other thing you need to account for, though, that these problems give you is taxes and insurance. And these are typically your annual cost. So we need to get these broken down into a monthly cost. So for your tax, it's going to be $1,500 divided by 12, and your insurance is going to be $1,200 divided by 12. And then your total monthly payment in this circumstance is going to be your loan payment plus $1,500 divided by 12 is your tax is going to be $125 a month, and your insurance is going to be $100 a month. So $1,200 divided by 12. So monthly payment for this circumstance $948 plus $125 plus $100 is $1,173 a month. All right, so let's take a look at these next two examples, and hopefully this sets you up for your assignments. So Perez family is planning to buy a $90,000 house. Suppose the family gets a loan of 80% of the price of the house, and this is a 25-year loan at 10%. So what will the family's down payment be on the loan? So the down payment looks like it's going to be 20% of the house because they're getting a loan for 80% of the price. So the down payment will be $90,000 times 20%. This is a pretty nice math problem. So this is going to be $18,000 for a down payment for this circumstance. And this is coming from exercise 20 on page 802. And then the question is, what will their total monthly payment be, including taxes and insurance? Okay, so this is, according to the problem, at $810 annually for taxes and insurance. Okay, so the total monthly payment is going to be, you follow the table again. Oh, one thing we do need to calculate is the amount of the loan. So we know that since our down payment is $18,000, that $90,000 minus $18,000 will give you the amount of the loan. So we have 72 1,000s. So if we go to our table for 25 years, 10%, that's going to match $9.09 per thousand. So we're going to be paying $9.09 72 times. And then we're going to divide the insurance and taxes by 12. And this will get us our total monthly payment. So let's calculate that. 909 times 72 plus 810 divided by 12. So we're looking at a monthly payment of $720.98. All right, let's crank through this is the last example I've given you guys. So this is from exercise 23 on page 802. The Bixley family has a $50,000 mortgage loan at 10% for 30 years. So definitely refer to the question if there's any information missing here, but the family's monthly mortgage payment, if you match the table again, 10% over 30 years, it's going to give you 8.78 when you match that on the table. And I really recommend that you try and follow that to make sure you can match it. So the monthly mortgage payment is for 50,000. So 8.78 times 50,000, that's $439. How many payments will the family have to make in all? So this is a 30-year, right? 30-year and monthly payments. So over 30 years, you have 12 months each year. So we're looking at 360 payments. $439. All right, so what is the total amount the family will pay for principal and interest? So we know that this is their monthly payment. This is how many times they're going to be paying it. So to figure out the total amount, we're going to multiply those out. $439 times 360 payments means that their total pay is going to be $158,040. And this is how banks make their money, right? They're loaning this much money, but over time, this family is going to be paying this amount to borrow that money at these specific parameters. So I hope that these exercises, seeing them worked out, will assist you when you do your problems. Please reach out with questions, comments, or anything of that sort. Once again, I apologize that this had to come via recording versus a circumstance where we could be going through the content together, but I hope it helps. Good luck.